right. Hello, everyone. There we go. Thank you for coming. QR code is here, and I'll have it on at the end. And let's get started. My name is Lance Finney. I'm an Angular developer with a company called Inficon, and I'm a Google developer expert in Angular, and I'm going to talk about the Angular Renaissance. And if you want to talk about a renaissance, a rebirth, it's helpful to know what's being reborn. So I'll start with a brief history of Angular. AngularJS was created in 2010, and it kind of changed the way web apps were created. It was the first real web framework in the way that we think of them now. It created the world that includes React and Svelte and Vue and all of the things like that today. And it took the development world by storm. It was really good for the time. But it didn't take long before the Angular team at Google realized there were some core architectural issues with it. So they decided to go back to the drawing board and start from scratch and create Angular. This was a completely new framework. It wasn't just a slightly different logo. It wasn't just dropping the JS from the name. It was a totally new framework with no real migration path for any user from the old way to the new way. And even though it was a much, much better framework than what it replaced, the lack of that migration path really hurt the community, and a lot of people moved away and went to React or whatever. But those who stuck around, like me, were rewarded with a much better framework than what we had before. However, it didn't take long before the Angular team realized there were some problems with that architecture as well, and so they needed to rewrite it again. But they learned their lesson. They didn't want to make the community go through the chaos of the full rewrite with no migration path. So they did something that was kind of amazing. They rewrote the compiler and the renderer as we were all using the framework, kind of like replacing the engine on an airplane while it's in the sky. And that was really good, much better than the original approach, but the downside was that there wasn't a whole lot that we saw as developers that was new. And for a while, it felt like Angular was stagnant. But the promise that they gave us is that this change, this Project Ivy, which worked on the internals, would unlock a whole bunch of features and innovation for us. And that promise turned out to be true. And about a year and a half ago, when Angular 17 came out, there was so much change and so much new buzz about Angular for the first time in years that people really started calling it the Angular Renaissance. They gave it a new logo. There was a whole lot of new behavior, a lot of new features. Where we are now is Angular 19, which came out a couple months ago. Angular 20 is supposed to come out by the end of this month. So now that we're going to talk about the Renaissance, I want to bring in some friends who are going to help. And Michelangelo, Raphael, Leonardo, and Donatello, they know a lot about the Renaissance, so I thought they'd help us. I'm going to talk about 4 different topics with my friends. The first of these is standalone components, and Raphael is going to help us. So what does standalone component mean? If you use any of the other frameworks, you've always had standalone components. Angular was kind of weird in that its components were not truly standalone. The component file was not something that could be independently compiled. It was the only one of the major frameworks where you couldn't just compile that component. You also had to compile another file. There was something called an ng module, which is where your component was registered. And if you had any dependencies in your component, you had to mention them in that ng module. So you're kind of bouncing back and forth between these 2 files just to deal with your component, which was kind of weird. But now components are essentially their own modules. They contain everything that they need, they have their dependencies declared right within them, and they can be compiled on their own. This just gives us a simpler mental model, and then some technical advantages I'll talk about later. So let's look at an example. On the left, we have a component that Raphael created to model their sewer. The only state in this model, or in this component, is whether the manhole is opened. It's a Boolean. If the manhole is open, then we show a welcome message in another component. And there's a button there that you can open or close the manhole, and the text on the button will change depending upon whether it's open or closed. To change that to standalone, it's a pretty small change. We add a line that says that it's standalone. that gets added to the decorator at the top. Now, this isn't necessary anymore. It was necessary for the first couple versions that had standalone. It is now the default, and if you don't have standalone, you have to say standalone false. But just putting there to be explicit. The important line is the next one. We now declare our dependencies right within the component. This component uses that welcome component, and so we declare it as a dependency with that import, and it uses ngIf to decide whether to show that welcome component, and so we import that as well. So we end up adding 1 or 2 lines of code to our component. Big deal? Maybe. And yet often when we add code, we think that's a bad thing. So is it good that we added 1 or 2 lines of code? Well, yeah, overall, because adding this 1 or 2 lines of code allows us to get rid of entire files in other places. That other file is the module. So here's the ng module, that registry file that was associated with the component. In its decorator, it declares the components that it owns. And it owns both that sewer component and the welcome component. And since it owns both of them together, that's how the dependency is set up, and that's how the sewer component can use the welcome component. So that's part of what ended up in that import line. The other part is in this imports here. Common module is a big thing that provides a whole bunch of stuff, including that ngIf. So the 1 line that got added was part of the 2 lines on this other file. Now the rest of this file, is the routing. So when we route to this module, it decides to show us that component. And I told you where everything else goes, but where does that routing go? It kind of disappears. The reason it disappears is because we don't need that file at all anymore. And we can see how that works when we look at the overall bootstrap, the overall setup of our application. And that's really where the hard work is in adapting to standalone components. In the components itself, it's just 1 or 2 lines. But the rest of your application infrastructure is going to change like what we see here. And part of it is how we bootstrap the overall app. What we see on the left is the old way, on the right is the new way. At the top of both, we see the main.ts, which is the core file with an Angular application. And both of them bootstrap us to the main component that we use in our application. But in the old way, it was a double step. First, at the top, we have to use the platform browser dynamic to bootstrap to the module. And in that module, down at the bottom, we can see that we bootstrap to the app component. It's this double step of bootstrapping. On the right, we see we still have some bootstrapping, but it's a different API. It's called Bootstrap Application, and it bootstraps directly to that component. So previously, it was main to module to component, and now it's main directly to component. Now, the rest of what used to be in this app module still is necessary. It's the routing that routed us to that sewer module in the first place. And we still need that basic logic, but it also has changed. Previously, we set that up with router module for root, and we declared it at the bottom, and we had our roots defined in this array, and part of that definition was load children, which said route us to that module. Well, that module doesn't exist anymore. Instead, what we have now is provide router, so a different file, or a different API, and load component, again a different API, that loads directly to that component. So before, we went from app module to sewer component, and now we go app module to sewer component directly. We just don't need these module files anymore. They just disappear. So yeah, for me, it's definitely worth dropping 2 lines, or adding 2 lines to our component. And this actually is what they wanted for Angular from the beginning. In the alphas and betas and early release candidates of Angular 2, components were standalone. They declared their dependencies right there. But very late in the game, they realized there was a corner case with some dynamic components that the compiler at the time couldn't handle, and so they had to add this module concept for this corner case. And no one really liked it, but we worked with it. But because they did Project Ivy and rewrote the compiler and renderer We no longer need that. The compiler now can handle all those corner cases by itself, and we can have the original vision of standalone components like all the other frameworks. The status of this, it was introduced in Angular 14 and 15. It was default for new components in 17, and now in 19, it is truly the default. You don't even have to say in your components that they're standalone. So thank you, Raphael. Now Leonardo is going to help us talk about control flow syntax. Here we have pretty much the same sewer component as we had before, but there's a little bit of a difference. If the manhole is open, we welcome people in. But if the manhole is closed, we have an else there that goes to closed and says stay out. So we have this if-else construct in there. We have a way in our template of doing if-else. That's not something HTML can do natively, so Angular had to provide it. And the way Angular provided it initially was through this structural directive called ngIf. So inside the thing that it was controlling, we would put this star ngIf and then our expression. And if we had an else, then we would do colon else and then a variable referring to something else somewhere in our file, another ng template somewhere in that same file called, in this case, hash close. That hashtag is what's declaring the variable. And this works, but it's kind of weird. You know, there's really nowhere else in programming I know of where you put your if construct in the thing that you're trying to decide. It's just kind of weird. On the right, we have the new way. If manhole open, show one thing. Else, show another. Hey, that feels like JavaScript. Anyone who has worked in any C-based programming language can read what's on the right. The left is kind of weird, the right makes sense. Now sure, there's the @ signs, and that is a weird new thing. It's necessary because this is kind of HTML and it's a different construct, so there's this thing for Angular to escape out of it and use these special features. But otherwise, it's just an if-else. And even better, if this were a case where we had if, then else if, else if, else if, else, it's easy to do here, just like you would do in TypeScript. In the old way, we would have to put another ngIf with the else on the ng template, and then on the next ng template, we'd have to do that same thing again. And those templates could actually be anywhere in your file, so reading what actually you have could be kind of difficult, because it's essentially go-to statements, and you're bouncing around in your file. But now it's just if, else if, else if, else. It makes so much more sense. Additionally, look at the imports line. We no longer need to import ngIf. ngIf was not built into Angular by default. It was in that common module or imported directly here. But now, that @if is built into Angular. We don't need to import it. So it's kind of nice. The next structure was for loops. The turtles love their pizzas, and they want to see a list of their pizzas. So a bulleted list for each pizza in that pizzas array. Let's get an index so we can say 1 sausage, 2 pepperoni, 3 cheese, whatever. And if there are no pizzas available, bummer. Again, this works, but it's kind of weird that we have the looping construct in the thing being looped. On the right, we have the new way. For every pizza in pizzas, okay, I'll come back to track. That's kind of weird. I'll come back to that. But for every pizza in pizzas, then we show what we have there. The $index is a variable that is given to us for free because we're inside a for. It just looks like code. And if there are no pizzas, we have this @empty, which is a free thing that we get with a for loop. We don't have to do another if. It's just an optional thing that we can do there. It's simpler to read. It looks like any for loop we would have in TypeScript, except for that thing. Oh yeah, and that track. What's that about? This is actually a huge performance thing. Imagine we have a list of 50 pizzas, and it's alphabetized. And we can change things in there, add, delete, whatever. And we rename one of the pizzas from sausage to Italian sausage, so it has to go to a different spot in the array. If we don't have something like track, Angular is going to look at that and say, well, things changed, but I don't know exactly what changed. I don't know if any of these things are the same thing that they were before. You know, I better just re-render everything. Wouldn't it be nice if we could say, You know, this is the unique key, this is the database key or whatever. These are the things that actually haven't changed. So even though it shifts because the sausage moved to a different spot around it, it's really the same thing. You don't need to do the effort of re-rendering it. That's what this does. Each pizza has a unique ID. We can say track by your unique ID, and it can then be able to tell, all right, this is the same thing as before and it's changed, so I need to re-render it, or this is the same thing as before and it hasn't changed, so I don't need to re-render it. It's a huge performance gain. We used to be able to do this with NG4, but it was a weird syntax, so almost no one ever did it. It's much simpler syntax now, and it's a better algorithm than it had before. And with that combination, they've now made it required. So you have to put a track when you do a for loop. The last change that's part of the control flow is switch. So here we want to show a different component for each of the turtles based on the color. So if we get a purple, we'll show Donatello, blue, Leonardo, et cetera, et cetera. If we don't match anything, we'll show their friend Splinter. So we do square brackets, ng switch, and then structural directive with a star for ng switch case. Again, it's inside the thing that it controls. And then at the end, a structural directive for ng switch default. Again, kind of weird. It works. You have to remember, when is it square brackets, when is it a structural directive. We have to import these things. The new way, at switch color, at case, at case, at case, at default. It's just programming. We don't need to import things. And there's actually better type safety here. All of these cases are strings, so color has to be a string at compile time. In the old way, there was no type safety on that. So, in summary, we have fewer imports, which means smaller bundles. That gives us better performance, and so does the track. Better type safety in our switch, better ergonomics, because it's just less weird. And there's easy migration with schematics that Angular gives us to convert your old version to the new version. This was in developer preview in 17, stable in 18, and those structural directives are going to be deprecated by the end of the month. Now Donatello is going to help us with deferrable views. So this is different than the other two things I've talked about. The first two things I talked about are things that we always were able to do before, but we now have better ways of doing it. This is actually something new. And not just new for Angular, it's new overall. Other frameworks don't have this. It is allowing us to do lazy loading at the component level. Now, we've had lazy loading in Angular for a long time, but it was always at the routing level. So if you change your application, go to a new page, we can lazily load everything on that page, say, anything that we get to by routing to it later, all of that bundle will be loaded after the fact from the server. And that is a huge performance improvement for us. But what if on that page at the bottom, there's a component that's really big, really heavy, and we don't want to load that until the user clicks a button or scrolls down to put it in view or something like that? We couldn't really do it before. There were a couple hacky workarounds that a few people did. No one did it really. But now it is an easy core part of the framework. And this is the basic syntax for it. Again, we use the @ sign, similar to what we saw in the previous section. We will say @defer, and then we have a block. Everything in that block will be hidden from view until some trigger happens. And in this case, the trigger is on idle. That's actually the default. We wouldn't need to put it here, but I just did it to be explicit. And idle means don't show this until the browser is done loading everything else, and the browser has the time to go grab this and then put it on the screen. And there are two components in this block. App idle is standalone. App non-standalone is not standalone. Both will be hidden until the trigger happens, but only the app idle will be truly lazily loaded. So that is an advantage of standalone components. So again, these will be completely hidden until the idle trigger is invoked. Then it will go fetch the things that are standalone, bring them in, and show them on the screen. And then we have a bunch of optional things. We can have a placeholder that shows before the trigger is invoked. So in this case, it will say this placeholder will go away after 2 seconds until that trigger is invoked. And optionally, we added a time on this. We're saying, let's show this for at least 2 seconds. And the reason we do that is otherwise it might show the placeholder for only like 2 milliseconds and be a weird flash and annoy the user because they won't know what they missed. So we show it for 2 seconds, give them a chance to see it. That's optional. The placeholder shows before the trigger. And once the trigger happens, then we have the loading placeholder, and that will show on the screen. And again, we're going to show that for a minimum of 1 second. And if there's some sort of network error while trying to load that bundle in, we'll show the error placeholder. And there are a bunch of triggers for this built in, and you can create your own. And I'm going to jump over to a live app to show this. So this is a step in a training course for a company I used to work for. I created this step for them. And what we see here is an example with idle. Down here we have 2 components. One is standalone, one is not. And I'm going to reload this, and you will see that it shows a placeholder for 2 seconds, and then it shows the 2 components. But the important part is over here, we can see the standalone component was bundled later. Now, this is a tiny application, so until idle is a short enough amount of time that as a human we can't really see the difference, but it truly was bundled separately and brought in later. We can see the difference better with some of the other triggers. One of the triggers, viewport. Bring this in from the server when it's on the screen. So here we have a scrollable pane, and at the bottom I have a really huge, big, ugly, hairy component that I don't want to be loaded in from the server unless the user scrolls down to it. So as I scroll down to it, we get this, and you can see it was loaded in from the server when it was scrolled into view. Another one is interaction. This click on this text to load is a placeholder, and so is this click on the button above to load is a placeholder. Both of these are set up so that if we click on something, it will be brought in. For the top one, if we click on the placeholder itself, then it gets brought in. And for the other one, the placeholder itself, I'm clicking here, is not the important thing, but it's this other button. You can direct it to another button. So I click on the button, and it brings it in. Now you can see it doesn't actually bring it in a second time from the server because it's already brought in, but if I had done it in the other order, the same behavior would have happened. Next we have hover. So I'm going to hover over the second one. So I come down here and hover over the button, and at that point it brings in the hover component, or I hover over that placeholder. We also have immediate, which will bring it in immediately, and that's really kind of hard to demonstrate because what's the difference between immediate and idle on a tiny app like this, but you can have it bring it in immediately. The last built-in one is timer. 1, 2, 3 seconds, 1, 2 while loading. There we get it. And you can see it came across the wire when the 3 seconds were done. And you can create your own trigger. We have a placeholder down here, and then when the value in this box gets bigger than 3, placeholder for 2 seconds, and then we load it in. So this is our new feature. It's in developer preview in 17, fully stable in 18. And just a note, because of that weird @ syntax, which is not really something in HTML, if you're using this, you'll need to upgrade your prettier version to at least 3.1 in order to be able to use it. And now we're going to talk about signals. And this is going to be the rest of the talk, because this is really the biggest change that has happened to Angular in a long time. So what are signals? What is Michelangelo helping us with? They're a new synchronous reactive primitive. So why do I say new in quotes? Well, it's new to Angular, but you've actually seen this concept before, even if you haven't thought about it, and I'll show you an example in a moment. The other part of it is it's a synchronous reactive primitive. And that's in comparison to asynchronous reactive primitives, promises and observables. So with an observable, that knows everything about time. You can say, do this delayed by 2 seconds, or debounce. Like if I'm typing quickly, wait until I'm not typing for half a second before you do anything. Or keep track of the last 7 values, or things like that. Signals are a lot simpler than that. They don't have a concept of time. They're essentially just a box with a value in it. But that's not all, because they're also reactive. And that's the important part. It's a box with a value that knows how to pay attention to other signals changing and knows how to notify other signals that they've changed. So when the value in that box changes, it can notify other things, or it can listen to other things changing. And you've seen something like this before, even if it's not implemented in signals, if you have a spreadsheet. I'm sure we've all done something like this, where we have a bunch of input values at the top and then a calculation at the bottom. You can think of this as a good metaphor for signals. The number of guests is a box that contains, in this case, either 50 or 75. And at any point, if I change that value, immediately the total cost at the bottom is reevaluated, because that's another computed signal that has a value in a box that is calculated based on other things. These are just boxes with values that can calculate themselves based on these other boxes with values and notify each other when they're changed. That's essentially what signals are. So if they're not as powerful as observables, what's the advantage? Well, on one hand, it gives us simpler execution than we can do a lot of time with observables. RxJS is really powerful, but it can be a lot. But the more important thing and the true motivation for this is that it improves change detection. So what does that mean for us? The way change detection has happened with Angular from the beginning is with a third-party library called Zones. And Zones feels like magic the first time you see it. The first time you're working with a small Angular application and you make a change here in one part of your application, and then suddenly this other part of the application re-renders it automatically, and you didn't do anything to write that up. Like, I've seen people just be amazed and wowed. Like, that's so great. I didn't have to write anything to wire that up. How did that work? Well, it's just Zones magic. Zones is watching your application and re-rendering it when necessary, which is great until it isn't. The way Zones works basically, well, we'll see an example with this application. Imagine we have a root component and a couple child components and our grandchild components, and imagine this is arbitrarily large. And there's a change. User interacts somehow with the child component. What will happen is that there will be a traversal from the root through the entire tree. So Zones is going to go through every single component, starting from the root, and say, hey, have you changed? Do I need to re-render you? Have you changed? Do I need to re-render you? Have you changed? And it's a very fast traversal, but it's still a traversal. And on a big tree, it takes time. So that can be a bit of a problem. Some other problems with Zones. It's a third-party library, so it's adding to your initial bundle. It's this other thing that you have to bring in order to make sure they catch all the corner cases. They have it run more than strictly necessary. And it uses something called monkey patching, which means it's actually changing the JavaScript in your browser. And some people have a huge philosophical problem with this thing changing their JavaScript, but even beyond that, there's a technical issue. Some things in JavaScript can't be monkey patched. Async await can't be monkey patched. So they have to do a lot of extra code to simulate monkey patching for async await, and more things like that are coming into JavaScript. Zones is just showing its age. Now, it's not the only way we do change detection in Angular. There's also onPush. You can declare a particular component uses onPush. And what that means is when that change happens to the child, there's still a traversal, but it's only from the root to that child. So the whole rest of the tree doesn't get traversed. So that's a huge performance gain. But there's some downsides of this. One is it's less magic, so you as a developer have to take more responsibility to make sure things happen. You have to know when to force a re-render. The other downside is that traversal stops at the onPush component, which means if that grandchild component expects to be in a zone environment in order to re-render, it won't be notified, and it won't re-render. So Signals is going to change this. With signal-based change detection, the change will happen to child, and child will be re-rendered, and that's it. And even better than that, actually, the individual lines of the child that have changed will be re-rendered. Huge performance advantage. So what's the disadvantage of this? It doesn't actually exist yet, but they're working on it, and we're getting there. And even though we don't have this final thing yet, Signals is still really, really valuable. So now that I've talked about these in theory, let's look at what signals is in practice. Again, we're coming back to our sewer component where the only state in here is a manhole open Boolean. When we want to use a signal instead of zones, we wrap that state in signal. We say, signal false instead of just false. And that means that that manhole open is now not a Boolean, but it's a writable signal that contains a Boolean. So when we want to get that value out of that signal in our template, we use parentheses to get that value out. So do we show our welcome message, manhole open? Yes or no? What do we want to say on our button, close manhole or open manhole? Ask manhole open, and then get that value. And then our button, instead of the click, just flipping that value in place, it gets the value out using the parentheses and then sets to put it right back in. And when that set happens, the other two spots that are using manhole open will notify the template that these specific lines in the component need to be re-rendered, which is pretty awesome. Now there's another syntax that we can do for this. These are just showing the basic syntax. Both of these are equally valid. There's sometimes that one is better than the other, but it's all valid. So let's say instead of wanting to do the button text in the template like this, we want to do it in our TypeScript. And we can do that by calculating a computed signal. This is kind of like the bottom cell on our spreadsheet. So what we're saying here is now the button text is a signal. It's not a writable signal, so we'll never be able to call set or anything like that on it, but it's a signal that is calculated whenever the signals in its callback are changed. So we use a computed function, give it a callback, and have some signals that are evaluated in there. And whenever manhole open is changed, the value of button text will be changed, just like that last cell on the spreadsheet is changed when we change the number of guests. And now that we have a signal, we can get the value out in the template, parentheses, we're done. The other change we can make is if we want to move the button click into the TypeScript, we can call that on a method. And that'd be fine, and we could do that with a set. But another option we have here in TypeScript, not in the template, but in the TypeScript, is update. Since our set is just taking the old value and flipping it and putting back, it's really perfectly suited for update. Instead of set, which you can put anything you want in there, update gives you the old value in a callback, and then you can calculate the new value based on the old value. So we'll get the old value in this update, in this callback, toggle it, and put it right back in, and that is how our button works. Set would be just as valid here. Update is not better, but it's more convenient in this case. Computed, there are definitely times you want to use computed instead of doing things in your template, because computed can be a lot more complicated than this. So those are the basics. Let's see this with a more complicated application that starts to use RxJS. So here's an application that Michelangelo put together to keep track of his bad guys. It has a reactive form control at the top. That's a filter. By default, there's no value in there, but you can type values in there. And whether it's the initial empty value or as we type values, it'll send that to the back end, and in the server, it will give us any of the matches for that. And that'll show up on the list at the bottom. And when the user clicks on any of those, it selects that particular bad guy, keeps track of the ID of that selected bad guy, and then uses that to populate the detail pane on the right. And here's the template for it. On the left, we see in a pure RxJS observable approach, we're going to have our list. That's going to come from an observable, so we use async pipe. We have our selected ID. The parent component is the single source of truth for what the selected ID is. So we want to be able to pass that down to show the highlight. Use async pipe for that. When the child component sends the selected ID up, we're going to next onto a subject to keep track of that state. And for the detail view, that's going to be another observable that has all the selected bad guy after making the call to the backend. And again, we use the async pipe. We want to be in the signal environment here because we're in a template so that we can have better change detection. And so after we make the change, and on the next slide, I'll show you the TypeScript for this change. Instead of using an async pipe, we use our parentheses. These are just signals. We get our value out. And if either of those things change, we'll re-render that component. And when we get the value from the child component and want to set it on our state, instead of using next on a subject, we set on our signal. So what does this look like in our code? Two different versions. On the left, it's the observable only way. On the right, it's the signal-based way. Both versions inject a service to load the data from the back end. Both of them use a reactive form control to define our filter. And then they diverge. The other state in them is the selected ID. For one, it's a subject. For the other, it's a signal. How do we show the contents in that table? Well, our filtered list is going to be in an observable environment because we start with an observable. The reactive form control gives us an observable of all the values that change on as we type in there. We start with the initial value, then we get a new value every time we change. We use it to bounce on there so that we, as we're typing really quickly, we don't slam the server. So we wait 250 milliseconds until things have settled down. That's when we make the call to the backend. And we use switch map to make a call to the backend. And however long the lag is for the backend, whenever that value comes back, that's what we have in our observable, so our async pipe can show it on the screen. The other thing is the selected bad guy. Initially, the selected ID subject doesn't have a value, but when it gets a value, we will switch map on that value to make a call to the back end, and then the selected bad guy observable has that information. Again, we use the async pipe. I'm going to zoom in a little bit here for the selected version. Sorry, signal-based version. The selected ID is now a signal. And we're actually in kind of an awkward state here, because there's a lot of stuff here that signals can't do. For now, forms don't give us signals, so we have to get that value as an observable, not as a signal. And then the debounce time, waiting for 250 milliseconds, signals can't do that. Signals don't know about time, so that has to be in the observable. And the switch map and the call to the back end and waiting however long the lag is, signals can't do that. So all of that has to be in observable space. But we want a signal at the end to put on our template, so we wrap it in toSignal, and then we have our signal. Now, an observable is perfectly happy with not having a value yet, because it knows that time happens. Signals can't do that. It has to have a value, so we give it an initial value of an empty array so that there's something to populate. If we didn't do this, then it would have to be a signal of bad guy array or undefined, and then our template would have to deal with that. It's easier just to give it an initial value. For the selected bad guy, it's actually a little more complicated because we start with a signal. That selected ID is a signal. But then we need to do observable things. The switch map to call to the back end and wait, that's an observable space. So we start with the signal, then we call toObservable to change it to an observable context, do the observable things, then toSignal at the end to put it on our template. Feels kind of nasty. Would it be good if there's a better way? Initially, when signals came out, there wasn't, but now there is. We have something called RxResource. An RxResource is this utility that will start with a signal and end with a signal, but then does all of the observable stuff internally for us. So this would be for another application that Michelangelo wrote to keep track of the allies. And we might want to look at it ascending or descending. So we'll have a signal that says ascending or descending. And depending upon the value of that signal, that will be passed into the resource using the request. So every time that value changes, request will get a new value and pass it in then to the loader, which every time that value changes is going to make a separate call to the backend with a different param to pass into the HTML to get a different value. So the input is a signal. Internally, it's doing HTTP, and the output is a bunch of signals. Value is a signal with the value of the allies that came in. Loading is a signal. Has it loaded or not? Are we in the process of loading to show a spinner? Error is a signal. Status overall is a signal. So a lot of things that we would normally have to do with putting a tap in there to say we're loading at the beginning and then a finalize at the end and all, it's automatically done for us. All that observable behavior and call status is automatically done for us inside the RxResource. This is experimental in Angular 19 and 20, and if you prefer fetch for promise-based interactions instead of RxJS, there's also a resource, which otherwise behaves the same. So what does it look like to change our application to use this Rx resource? Now the filtered list has to start with an observable because it's so far, as I said, forms don't give us signals. So at some point we need to convert this to a signal to give it to our RxJS. So we still need a toSignal. But instead of toSignaling everything, it's toSignaling the input. So we listen to the value changes with our initial value, and we wrap that into signal. So now we have a signal that has whatever the filter is. And then we pass that into our Rx resource to make a separate call to the backend every time the filter list changes. And at the end, we have signals. The selected bad guy is an even better change because again, we start with a signal, then we have to go to observable and do our switch map and all that, and then get it back to a signal at the end. Well, we're starting with a signal, so our request just uses that signal. And whether the request has a value or not will tell us whether we make a call to the backend or just return undefined. And at the end, we get our signals. How does this change our template? Well, the two of the things that previously used parentheses to get the value out of the signal now do .value parentheses to get the value of that signal that's inside the resource. And if we wanted to do a spinner or an error, it's a lot easier now than it was before. Michelangelo didn't do error handling. Bad Michelangelo. Additionally, there's another type of resource called HTTP resource, which is built on top of it. You can just pass in the URL in a callback, and then you have access to all of those signals. That's the simplest version of it. There's other versions you can pass in params and a default value and a bunch of other things. But the simplest version, you just pass in a string and then you get all of that signal goodness at the end. This is brand new, 19.2. It's experimental now and it'll still be experimental in 20. And a note, I've mentioned several times, these resources do switch map internally, which means these are great for get, but don't do put, post, delete with these. You can. There's nothing to stop you from having the HTTP call inside your Rx resource be a put, but you shouldn't do that. Imagine that you have a delete set up there and you're trying to delete 5 things and you use this thing. Well, it might call them so quickly that the switch map will cancel all of them but the last one, and you won't actually get all of your mutations that you expect. So for the time being, we have this great feature for get, not for put, post, delete. Those will come in the future. Couple more, 3 more slides for parts of the API. One is what do you want to do if some sort of effect at the end, side effect. You know, we have this reactive thing and we want to do something as a result. In the RxJS observable world, you subscribe. So we start with this filter text observable, we subscribe to it, we get our value each time a new value comes in, we pass that to update query params, and that updates our query params for us. With signals, we start with a filter text signal, and we use effect with a callback that pulls the value out of that signal inside the effect. Every time that signal has a new value, it passes it to update query params. Same basic behavior, with the advantage that we don't need to bother with subscription cleanup. Next part of queries, inputs and outputs. For a long time in Angular, the way that a component would deal with the template itself or the parent is through these decorator-based properties. So if you want to inspect something that is in the template, you can use viewChild. If you want to do something with something that is content projected in, you do that with content child or children. If you want to get a value from the parent, you use input. If you want to send an event to the parent, you use output. They're now functions that do all of these things. So there's a viewChild function that gives you a signal that you can work with. And same with content children. Input, you can get that in from the parent, and there's more API to this than I'm showing here. There's also a new output. It's not actually signal-based. It's still events, but the change happened at the same time with the same basic API, so it kind of gets thrown in. And the last part of the API is link signal. So what if you loved that computed, but didn't like that you couldn't set anything on it? That's what link signal is for. So the way we declared this linked signal is exactly the same as the way we declared that computed before, except it says linked signal instead of computed, and it has a callback that uses the manhole open, and then we have a signal, but this is a writable signal. So then we could have another function to change the label after the fact, overriding what happened. Okay. And whichever change is the last one is the one that will come in. This is in preview in 19, will be stable in 20. So the status of all this, the first parts were in developer preview in 16. Most of it is stable in 19, not all of it. There's a link at the bottom. We'll show you all the details. Signal-based components, change detections, and forums are to come. A lot of other improvements as well. Faster builds. SSR for server-side running and incremental hydration. Atlet lets you do variables in the template. There are migration schematics for a lot of these changes. HMR means that as you make changes in your editor to the template, it automatically changes it in your browser, and you don't even need to reload the app. A lot of documentation, a lot of more information in these release notes. And with that, thank you for coming. There's my socials and the QR code if you want to see the slides. Thank you.